For GE Digital, we have Victor Kingery, the Senior Director of Industries, who will be on our panel, and Carl Schneebauer from MPDV MES Solutions will be also participating in our panel. So let's go ahead and okay, we can start the questions. Anybody want to jump in here? Get this rolling.
Sure, why not? Christian, do you say you have an assessment tool right now that you can go into any manufacturing company and do an assessment of their digital manufacturing readiness level?
So our assessment is this kind of maturity metrics you have seen, and of course behind of every level we have a long list of description, and we are, I'm coming from the IT, but together with our corporate digital engineering team, we are assessing plant by plant, then based on the related level. So going through, so at the end, it's like a star rating, so that the plant can assess for getting the next level, and then it's getting its kind of visibility that they have reached the level 3, 4, 5 in the maturity model.
I would say we have a similar. In GE we have a similar model. I noticed what you had up there as far as the frameworks. We have something as well. Looks at MES, machine connectivity, PLM, MBE, and has some ratings. I think we're L0 to L4, similar to what they have. And we're actually in the process right now of aligning that across all of GE, so that we're all working on the same.
I'm just my just kind of in general, with this whole notion of the digital thread across or what we're calling the digital transformation of the digital factory, is that it kind of follows in line with the same notion we were talking about, the life cycle, the digital thread and the life cycle of the product. As we move into the factory, that digital thread continues on the production lines in the plant floor, because there's a connection directly to the product design. And then of course there's digital manufacturing aspect of it. There's simulation of the production processes themselves that's digital. You know, a lot of this has been going on for years, but it's really these kind of disparate, well, they're not really disparate now, but they're all separate types of technologies that are all coming across. And I think the notion of the digital thread really exemplifies where we're going with this. And of course, then we bring in all the aspects of maintenance and quality assurance, and of course optimization and continuous process improvement. I think what really is interesting is that all these notions of continuous process improvement, lean manufacturing, all these things, they're old concepts. And we were talking about this back in the 80s. That being said, these are very sound principles. The difference today is with the technologies that we have in terms of predictive, prescriptive analytics, we can take all these basic good principles and we can really actually implement them with the data that we have in the digital thread. And we can actually do continuous process improvement. We can actually close that, what we call that PLM loop, if you will, or the loop between the design as built to the as designed loop. and not only validate what we're doing, but start to continuously improve the process through the digital thread.
Over here for Bryce and Christian, I guess. What would the big ROI on that actually looked at?
So overall digital thread, I mean, we see in engineering, we see huge amounts of reduced engineering hours as far as design. We actually see, I think, the most benefit though on our services side. So being able to create this digital twin, being able to model and run scenarios for assets out in the field, I think is huge. Both from while it's there and maintaining it, being able to do better RMD of those assets based on the digital thread and the knowledge that we've gained. And then also, and the reason why we picked our manufacturing facility is the ability when the material comes back to learn from it. We expect to drive out huge amounts of cost. I mean, that's part of it. I mean, there's other things that we expect. We expect NPI cycle times to be dramatically reduced.
From our side, so we have a lot of factories doing a similar thing, so stamping, molding, plating, assembly. And we have connected 5,500 machines already in a kind of hard-coded way that you can really compare now the kind of performance, I mean OEE, scrap, and all of that in a way that it's really comparable around businesses, around the plants. And this is driving, of course, then also the SAP transaction directly. We are creating out of the shop floor system 3 million SAP transactions each month to really book it into the cost accounting, really see the manufacturing variance directly from the shop floor, electrical signal, book it into SAP cost accounting. So that's hard-coded, hardwired. There's nothing tweaked, so that's going into the books. And then you can come to a total different level of measurement and comparison between the plants, between the technology, and can really compare that in a much more standardized way. That's one big thing where we have focused a lot on the standardization in our first step. And now coming with the new tools and new technology, of course, more deep in detail on the equipment side and so on, just as an additional value.
Okay, I have the mic, so I can ask a question now. No, that's fine. You're all good. So, based on your responses, I do have a question for Bryce, but I'm going to shamelessly plug an upcoming workshop since Dean asked the question about maturity, and you guys said you have work or some processes around it. At NIST in April, Dean's organization is actually coordinating the Model-Based Enterprise Summit, and NIST is hosting a workshop during that summit to look at the maturity model that DoD has. One thing DoD has said that they're struggling with when suppliers or contractors to them come and say this is our maturity, they're seeing a discrepancy between how they're doing those assessments. So they've asked NIST to come up with a guidebook on how to assess the maturity. After they do that assessment, what does it mean? And then what is a minimum level of model-based enterprise? So I'd invite you all to come out in April to that free workshop and give your input because that may end up turning into a standard at some point. Bryce, on the work that you guys are doing with the metrics that you're collecting in the dashboards, you said the operators look at those dashboards as a management tool. So one of the things that you can do with some of this monitoring that you're doing is looking at machine load on the spindle or energy usage to see if the machine is actually producing swarf, to see if they're actually doing something instead of just turning the spindle without load. Are you collecting information like that to make sure that the operators aren't just turning the machine on and going on a smoke break, or actually trying to look at doing the maximum efficiency out of that machine?
So we are, yes. I didn't mention that in there, but for machines that provide that information, we are. For some of our older machines, we have not gone back and retrofit and tried to collect spindle load. But we're actually working on monitoring the horsepower of spindles and doing adaptive spindle control. So we're looking at not only monitoring it, but trying to teach the program what looks right. And so we can run the program, you know, I think just naturally operators will sort of dial it back to be, you know, maybe run at 80, 85% feed rate to be careful. And sometimes there's good reasons for that. But what we're going to do is we're going to start looking at adaptive spindle control where we crank it up, maybe run at 100, 120%, and you try and maintain a constant horsepower. And then as you get into maybe tough spots in the forging, it automatically slows down, keeps in constant horsepower and speeds back up. We expect to, and so we're just starting to pilot it now. We're expecting to see reduced tool breakages. We're expecting to see increased productivity, better quality, and it could change the way we're working with operations right now. But could change the way that operators work because technically it should take them away. They don't need to be standing next to the machine anymore, right? So maybe they can operate 2 or 3 machines. So that's something we're piloting. Yes. I mean, we're doing some other things as well that I mentioned. We're trying to take CMM, so we you know, manufacture parts and they go through quality and they get CMM'd. And so what we're going to do is today, the operator doesn't see that feedback. You know, it could be a good part or a bad part, they don't know. So what we're going to do is we're going to take and put line side or machine side visualization of the parts that they're making so they can get as real time as possible feedback that says for the key attributes which ones are trending out or were their parts good or not, so that they can. And the expectation, so again, it's a pilot. The expectation is that the operator takes some action, right? But that's what we got to work through. Is it the operator's responsibility? Is it the line leader's or quality leader? So we're working through that aspect.
Bryce, not sure if this is on or not. On the ROI topic, I know that Rob, you had a great presentation yesterday, and you talked about it today also, Bryce, in the reman. You know, used to bring the locomotives in and basically tear down everything, right? All the parts and have to do an analysis. And in today's world, you're able to kind of diagnose it based on that digital history record of what that, you know, what the current condition is on those parts. So I'm sure there's a huge savings there, just from a labor standpoint, but I imagine inventory also. So if you could make a comment on that. And then Christian, on your side, in your business, I know there's a lot of potential inventory. We haven't talked a lot about inventory as far as an ROI, but you know, having that MES data and knowing when orders are required, when parts are required, what work in process is required, those kinds of things. Do you see a reduction in overall inventory and then indirect labor associated with material movements, those kinds of things?
Yeah, so I'll answer first. So definitely seeing productivity savings, definitely seeing material savings from applied material, because we do not apply as much new material as we used to. From an inventory perspective, I know in my heart there are savings. We haven't quantified them yet, and we frankly haven't held the plants accountable for driving the inventory down yet and resetting their ordering levels. You know, we haven't driven that action yet. But no doubt that we should.
From my side, historically, inventory management, material management is heavily SAP focused in our corporate. We are really an SAP shop on that. Nevertheless, also in SAP world, we're having a Kanban project, so we're driving a lot of in e-Kanban. And also on MES level, we want to go to more high junker concepts to have a production leveling, which is, of course, also something where we drive the operator more into the planning process. So that's really a change, in a paradigm change even from our planning world into a self-directed operations. That's the story about Endon fits in our world exactly. We're having a lot of momentum there to getting a self-directed organization that we can measure then lead time to respond and can get improvement on that. So that drives then to an overall faster response and at the end turns out into the inventory reduction. So that's really, so standard production plan, e-Kanban, and fast response. So all of the components will drive us into a lower inventory. That's what we believe.
So I have a question over here. So GE's been on a performance improvement bandwagon since the Jack Welch days and even prior to that. And some of the things that were described were things that we typically would expect to find being done in collaboration with sort of your operations improvement groups. And so I was just curious, to what extent are those integrated into the GE Brilliant Factory? Or is this now sort of the operators taking over everything and driving their own performance improvement?
No. So, one thing I didn't mention, we talked about we have a framework where we rate where we are on the Brilliant Factory scale. There's another axis, which is the lean axis. So we also rate the plants from a lean perspective. We're calling it a lean perspective, but it's more like a process improvement axis. We're calling it lean. I mean, there's some Six Sigma in there. There's some lean. So absolutely, that's part of the journey. I put up the screen, the real-time screen, which shows the red, the green, and whether the machine's on operations uses that. The historical look is what the lean team or the operational improvement team would use to say, how do I lean out this line, or how do I improve the process, or how do I take out a step, or how. So absolutely, we're going down this journey together.
One of the things that's kind of cool about this is all these sensors that are coming available, and the cost is coming down pretty quick. You look at the consumer market with things like Apple HomeKit or the Google Nest. And one of the things that kind of drives it, it seems like these Adreno boards and these Raspberry Pis, which, we've got kids in high school cracking out some crazy code already. Are you guys evaluating any of that, like how you're going to bring that in and take advantage of that on the shop floor? From one, how can that accelerate, maybe throw lots, a lot more sensors? And then the second thing is, how do we deal with that from maybe a security standpoint? Is there any concerns about that? Because it's kind of like the Wild West coming. Everybody's kind of sitting around. We've heard this analogy that we're all kind of sitting around, maybe drinking a little whiskey with our hands in our pockets, and we're waiting for someone to shoot. And like when they shoot, that's like throwing these sensors everywhere, and what it could mean to a factory from a security, because it's things we can walk in with and power up, and literally in 5 minutes we could be on a system, it seems like. But just wondering thoughts on those types of technologies.
From our side, of course, we are even delivering sensors, especially for the harsh environment. So I would not say the consumer sensors, from Apple or whatever, would be ideal for our manufacturing machines. I have not seen that in our factories, but for sure we are piloting a couple of scenarios where we are adding sensors and also things like Raspberry to make it more easy to get data, especially out of old machines and that. So from an IT security point of view, we believe, and that fits pretty good also in the GE picture, that we connected at the moment in the plant level data tank. You had a good name there as well, a data lake, right? Data lake, and we do not yet expose it, at least to my awareness, and it's a big corporate, directly into the internet, and so we keep it into the shop floor plant layer.
I think that's a great question, and it really has a lot of kind of pervasive nuances on where you focus on the answer. From a security standpoint, there's many different levels, right? So you hear about NIST, and you hear about the guys and gals that can drive up and down your street and open your garage door and steal your car based on all the electronics involved, right? So there's a lot of concern about those kinds of situations being applied to the industrial world and the industrial internet. So security is a really big issue. The focus on white lists as opposed to blacklist type technologies, embedding technologies as opposed to just putting up more firewalls, for example, that ultimately can be hacked. So you have multiple layers. One of the things we've done at GE is focus on the retrofitting and the whole infrastructure. So we call it factory as a service, and this whole infrastructure as far as what your Rob, you can probably talk a lot about this too if you have any questions. Rob Burnett is sitting here and he's involved at that security layer. But we've got a whole reference architecture now for our plants. So as we roll out these plants, we've got like 100 plants at GE identified this year. We'll make sure that this reference architecture from a security standpoint is met. Right, so for example, in our oil and gas business, we did a workout in Shawnee, Oklahoma, about 6 months or so ago, and we go to the plant, and they're all excited about all this new technology we're going to be able to put in from a software standpoint and so on. But when we started to really kind of peel away the onion and look at just the network requirements and the security requirements and the access and the single sign-on and the LDAPs and blah, and on and on, you know, it took 3 to 4 months just to kind of, you know, rationalize that part before we could begin the Brilliant Factory. But I agree with what you said, Christian, on the older machines, just even simple vibration analysis devices, a lot of visual devices in place now, right? So these webcams can really come in handy for those factories that have remote operations, right? Even in the oil and gas and telecom industries, they're being used. And then you supplant that with artificial intelligence and augmented reality. So when I pull up to do some service on a substation, for example, I have the ability just to take my iPad and scan the substation and see all the security components that are involved, any risks might be red, yellow, or green, for example. These kinds of technologies are really becoming pervasive, and so there's a lot involved in that question, but it's a great question. You know, security is the #1 issue, I think, in 2016 that I see from a lot of our customers.
I want to make a comment further on it. Again, great question. Going back to your comment about Raspberry Pi, doing boards, that kind of stuff. Everybody's getting in on the action right now. It's not high school, just high school kids, which is a good thing. But Raspberry Pi they're saying 40% of their sales are to manufacturing businesses, small businesses. Maybe it's probably more than that now. Companies as big as Microsoft are getting in on this. They're making this really interesting. The iconic software company is moving more and more into hardware. They have a platform for developing. They have a partnership or some kind of a partner agreement or something with Raspberry Pi to go on their Azure. Basically, I think it's on their Azure platform where you can go in and you can develop IoT and IoT types of applications and so forth on this platform that Microsoft has. So it's at all levels. So a small company, they're making some kind of devices or something. They're going to go out there and start building this stuff from scratch for everything. So it's becoming pervasive. It's really interesting. It's an interesting phenomenon that's happening right now.
I would also like to mention that in the shop floor, it's not simply about plugging NIST type of additional sensors to some machines. You always act in the context of best practices that are driven by the machine suppliers. And each machine supplier also has a roadmap with the customer on gradual improvement. So I really liked Christian's connected slide with these line type of manufacturing processes where this process interconnected sequential steps were shown by Tycho. And so the major aspect is really to getting that also from the MES software in a systematic concept, in a optimization-driven concept, and here is the value creation.
I mean, what the MES layer brings us, of course, as well, is then adding what we call smart data into the raw data. Means that once you know the sensor raw data, you can easily add what was the tool running, what was the machine running, what was the robot running, what all of that kind of additional ecosystem around that data tag needs to be somehow bring into alignment and bring into connection, and that's what MES helps us. But of course, we are also, like you said, going into looking into that cloud-based solution, looking into getting that outside TE. We're having the same challenge that we don't. I cannot bring it on a PowerPoint that we are doing it already. So, you know, Germans are very conservative in saying things which are not existing yet. So.
So we probably have time for a couple more questions. So and also.
And maybe we have time for the cookie box.
Yeah. And
So,
also
for those of you
Carl has something too.
who might have wondered, who want to drill deeper, whether it's GE or whether it's any MES product, we have here a book authored by our founder, Professor Kletti, MES, and for those of you who are interested to have a copy, please follow up with my colleague Armin, follow up with Christian. I would love to share the cookie box.
Thank you, Carl. So I think we have time for a couple more questions before we can head off to the festivities. If there's any more. Yes.
Christian, you had on one of your slides the progression going forward over the years, and you had additive manufacturing there. And I'm trying to understand where a company that makes hundreds of millions of products in the manufacturing processes, where you're incorporating additive in your processes.
You said adaptive manufacturing?
Additive. You have additive.
Additive manufacturing.
So digital print. I mean 3D printing.
Yeah, I mean that's of course it's going more into the tool shop and also in the prototyping area. I mean for a mass production like we are having very often, that's maybe not come so soon. But really for getting fast prototypes to the customer, that's helping us a lot.
And maybe to that point, I was wondering if you were incorporating.
Transportation, we make a big hunk of metal, right? So we don't have really complex parts. So where we're using it, again, is for fixturing, for MPIs, for molds, things like that, in order to get castings more quickly. But also for additive manufacturing, so repairs. So we'll take a big crankshaft, and if it's worn down, we might add material back to it and remachine it versus having to scrap the whole crankshaft. That's the application. One of the big applications we're looking at.
If I could just mention real quickly, Sal, if you're interested, you may be familiar with our Global Research Center, GRC, out of Schenectady, New York. We're heavily involved in a business-wide, multi-business workout, if you will, around additive manufacturing and how it's going to impact. We're standing up a strictly additive manufacturing plant outside of Pittsburgh that we call CATA, C-A-T-A. And so if you'd be interested in visiting that site, ARC wants to get more information, just let us know, either Claire or myself, we can put you in touch, and you can learn more about what we're doing at GE with additive manufacturing.
There's stuff to say.
One more shot for anybody, and then we'll probably wrap it up.
I did have one more question,
okay.
and it went to Bryce, and it had to do with you're the first person I've heard all week with regard to the actual collection of manufacturing data and tying it back to a unique digital twin model. And my question really gets down to, are you pulling data from from the field, when you're connecting to your engines in the field and driving the model to understand if you should pull it from the field earlier than expected based on its unique manufacturing characteristics?
We are not there yet. So no, we're just starting the journey on that. Right. So we're still developing the linkages, right? And we have a product that's out for, like I said, 8 years. Our assets last 30, 40 years. So this is a long-term play. We don't, an engine we're making today, we probably won't see for 8 years, right? But in the meantime, we'll be tracking it. If it's an asset, if it's one of, I think we have 12,000 assets that we do remote monitoring diagnostics on, we will be building those, I guess the data, right? And the idea is that there's value in it, but we're just starting the journey.
Yeah. Thank you.
I would also like to have a question for both of you about demand elasticity. So for you, Bryce, as well as for you, Christian, we live in a dynamic, interest-driven, hectic world where a financial crisis can come, a Chinese economic crisis can come, and all of a sudden you have demand drops or you have demand increases. So how do you manage capacities, and what's the importance of short-term scheduling? Could you cover or say your experience about your short-term scheduling needs in your plants?
Yes, we actually go through huge, we had probably our best year ever last year, and this year is going to be extremely challenging. We do. We have MESs in place. We have our ERPs in place. I don't know, I kind of feel like we have the needs met for that, for being able to do short-term planning, be able to do long-term planning, and we take some pretty aggressive actions to deal with those swings.
Yeah, from our side, we have the luxury, we have a pretty good supply ecosystem, which are where we are insourcing, outsourcing our tools based on the demand, so that we can leverage pretty good. And we even in the crisis 2008, there was not any layoff round in our corporate. So that was really a good signal that we are pretty right balanced on that forecast tools which we have. And coming back to the shop floor then, important is to plan the maintenance activities, the preventive, currently still preventive, right? Predictive is level 5, as you have seen. So to really have a good plan on the preventive maintenance activities and to have a good outlook on the setup optimization, so that's key, that really like a Formula One setup is needed, and then tool out, tool in, and machine continues to run, and that's key. So the visibility, it's not so much the capacity planning, it's really more a little bit the real-time outlook in the next three job orders, or that was also in your presentation, which drives to actionable improvement on the scheduling. Yeah.